so we're going to keep on rolling with some more examples of U substitution. And as we progress, they will get a little bit different. Maybe, hopefully you don't think they're more difficult, but they will get a little bit different. All right, so we're on number 14. All right, and I want to look at the integral of x squared plus 2 squared dx. Okay, now, because I see more than just x in a parenthesis and it's raised to a power, the first thought I have is that what's inside is probably the u. All right, but when I go to find du, okay, the problem with it is that I need another x. Okay, I need another x. If I only needed the 2, I could compensate for that. But because I need another x, I can't compensate for that. All right, so U substitution is not going to work. Okay, and again, I can't compensate for the x because I can't put an x in front of the integral. Okay, and so that's why I can't compensate for it. So then I have to ask myself, well, then how else could I do this problem? All right, and I hope that since it's only squared, that what comes to mind is that perhaps you just FOIL this out, right? X squared plus 2 times itself, right? And that will give you, let's see, x to the 4th plus 2x squared plus 2x squared gives me 4x squared, and then plus 4. All right, so if I FOIL it out, then it just becomes a polynomial that I need to integrate, and I don't need U substitution, right, for a polynomial. I literally just apply the power rule, divide by the new power, all right? Apply the power rule. When I divide by the new power, my coefficient becomes 4/3. All right, integrate a constant, and I get a constant times x, and then I need my plus c. All right, so please understand that just because we're learning U substitution does not mean you need it for every single problem. Okay? All right, let me give you another one. All right, how about x to the 3rd plus 6x to the 4th over x squared dx. Now, we've done problems like this before. Please, again, remember that we do not have a quotient rule, all right? And so perhaps you do think U substitution. Maybe that's the first thing that jumps into your head because that's the freshest, all right? Well, let's see. I really can't pick the top to be U because du is not allowed to be on the bottom. And if I pick the bottom to be U, then I've got way too many x's and things to have du on top. And so that's not going to work for me either. Okay? So again, U substitution is not going to help you here. All right? And so in this case, we're going to have to simplify what's already there by doing a little bit of division. All right? So we're going to divide x squared into x cubed and into 6x to the 4th. And then that gives us a much easier polynomial to work with. And then I can, again, apply some basic power rules. So we're going to add a power, divide by the new power, add a power, divide by the new power, and add c. Okay? All right. Let's keep it going. All right, number 16. All right, let's take a look at 4x to the 3rd minus 1 over 2x minus 1. Okay, all right, so in this problem, if you're thinking U substitution, okay, perhaps, again, you remember that the bottom, oh, and I need my dx, the bottom can't be du. The bottom can't be du, right? But even if you tried to make the top the u, right, and then to see what you get, all right, you don't have 12x squared anywhere, and you can't create it with the bottom, plus it can't be on the bottom, so that's not going to work. All right, so then maybe you say, okay, well, maybe the bottom is u, right? Well, then du would be 2 dx, and you got way more than that going on top. So how on earth am I going to do this problem? Well, similar to the last problem where we actually divided to simplify it, you're going to have to divide this, all right? But how on earth do you divide 2x minus 1 into 4x cubed minus 1? All right, so let me say that again. How do you divide 2x minus 1 into 4x cubed minus 1? All right, and maybe if I set it up like this, you'll get it, but you need to use long division. And the reason I left all this space is because when you do long division, you really should leave room for placeholders for missing x's, okay? So now we need to refresh our memory on how long division works. All right, so you really need to ask yourself, the first term in front times what will give you the first term underneath? All right, well, 2 times 2 would give me the 4, and x times x squared would give me the x cubed, okay? And then whatever term you put here on the top, you have to multiply it back by the 2x minus 1 and then line things up. So we get 4x cubed, then we get negative 2x squared. And then you're supposed to subtract what you just got, okay? And when you do that, that first term should cancel. Just make sure you also subtract the second term, which in this case will give me a positive 2x squared. And then you start the process over. The first term in front times what will give me this first term. Okay, now you're welcome to bring down the other stuff as well, because it is still there. All right, so the first term in front here times what will give me this first term, and all I need there is an x, and then I multiply it back. And I subtract. And when I do that, the 2x squares cancel out, and minus a negative gives me a positive 1x, and I can bring down the minus 1, okay? And then I need to ask myself, the 2x in front times what would give me a 1x? Well, that would be a 1/2. And that would in fact give me the 1x, let's see, minus a half. And then I need to subtract. And the 1x's will cancel. And I actually have negative 1 plus 1/2, which is negative 1/2. Now, because I don't have an x anymore, because all the x's are gone, there's no way to keep going. There's no way to go from a 2x to a negative 1/2 without an x. And so this negative 1/2 is your remainder, all right? And I don't know if you remember how remainders work with long division, but your remainder literally goes on top of your divisor, or what you were dividing by, which is 2x minus 1, okay? So what we have just done is we have turned this original integral into the integral of 2x squared plus x plus a half minus 1/2 over 2x minus 1. Now you're allowed to simplify that a little bit, but I'm going to leave it like that for now, okay? All right. Well, there's a lot of so now there's pieces to that are a lot easier to integrate, okay? And so I'm actually going to separate them because properties allow me to do that. I'm going to take the stuff I know that's easier to integrate. I'm going to separate that from the rest of it, okay? And I really don't want to leave this 1/2 on top of a fraction, so I'm going to factor that out of my integral. All right? All right, so I can apply power rules to all this stuff in the front, which I will do in a minute. But I do need to figure out how I'm going to integrate this 1 over 2x minus 1. And that is where our u substitution comes in. Okay, so we did one like this earlier. All right, the bottom is probably my u. All right, du would be 2 dx. So I'm actually missing a 2, which means I need an extra 1/2 in the front. All right, and then this becomes minus 1/4 times the integral of, well, u is on the bottom, so that's actually u to the -1, and everything else is du. Okay, and so I am now ready to integrate everything. All right, so I apply some power rules here to the front pieces. All right, and then I keep my minus 1/4, and the integral of u to the -1 is our natural log of the absolute value of u, right? And then we do plus c 1 time. And then I still have to make sure it all has x's in it, all right? So I need to replace u with 2x minus 1, right? I'm just going to be lazy and do it right here because I don't feel like rewriting everything. And then, of course, don't forget to throw your plus c back on there, all right? So if right away something can't be u, all right, you may have to do some simplifying before you get to it, okay? All right, now I've got lots of interesting examples for us, all right? Lots of different things going on, all right? Number 17. All right, so when I look at number 17, I see polynomial raised to a power. So my first thought is that what's inside the power, or what's inside the parentheses, is my u. The problem is I have nothing for my du, nothing, except for dx, I guess. So that's not going to work, okay? Well, it's not a division problem like the last one, so I can't simplify it like that. It's not a FOIL problem because technically it's got a root in it. So then I asked myself, well, gosh, is there any other way to write this? Okay, like, can I just rewrite it somehow? And I don't mean just changing it to a radical, okay? What I mean is, can I do something with this trinomial, all right? Well, what happens if I factor that trinomial? Let's see. That's going to give me x and x, same sign, both subtraction. What multiplies to be forward as to be 4. Ooh, so this trinomial can actually be written as x minus 2 squared. And then if I raise that to the 4/3, I can actually rewrite my integral. All right, how do you do a power raised to a power? Multiply. All right, 4/3 times 2 is 8/3. All right, and so I've rewritten my integral, and what's inside parentheses is a lot more simplified. So what if it is my u now? Then what would du be? 1 dx. Interesting. Well, that worked out really nice because that's what I have. And so what am I actually integrating is really just u to the 8/3 du. All right, and so that's where I add my power, divide by the new power, which means multiply by the reciprocal, and add c. And then last but not least, plug u back in. Just make sure it's the u that you actually used u substitution with, okay? You are not going to be able to change that back into the original trinomial, okay? Sometimes you just can't do it that way. Alrighty. Another example. All right, so this time, again, I see a parenthesis raised to a power. So let's see. Let's see if what's inside the parentheses could be my u. All right, du would be 1 dx. So I have that, but I have extra. Okay, so this one has extra. Now, I can take care of the 2, right? I can pull that out front because that's a coefficient, all right? So I can pull the 2 out front, and then that's not extra inside. But what is still extra is the x, okay? And I can't pull that to the front because it's an x. But I actually can do a little bit with extra, okay? Because I'm doing u substitution, all right, and right now the bottom is u squared, okay? If I can change the x, this extra piece, to be something with a u in it, I might be able to work with it. All right, so I'm going to use my equation right here, and I'm going to solve for x. So I'm just going to add 1 from the right to the left, and I've solved for x. And so when I come back over here, right, the 2 is still in front. The x minus 1 on the bottom is my u, and I'm going to bring it up, so it's going to become u to the negative 2. Then the x is my extra, and I just said x is equal to u plus 1. And then the dx, remember, is my du. All right, now that doesn't look a whole lot better, but I can actually distribute this u into those parentheses and add exponents. Oops. And then it looks more like a polynomial. All right, and since it looks more like a polynomial, I can treat it like a polynomial by applying some power rules. All right, and so I'm going to keep the 2 in front of everything. I'm going to have to apply some power rules. So I add a power, remember you can't add a power there. So that's the one that must be the natural log, the absolute value of u. All right, but then on the next one I can add a power, divide by the new power. And to finish, I'm going to distribute the 2 and plug that u back in. Let's see, so I'm going to distribute the 2, and that u goes to the bottom, plus c. All right, so that one is a very different one because we had extra, so we had to use our u equation to do a little solving, all right, and then we were able to make it work. All right, so let me give you another 1 or 2 like that. And then we'll stop the video. I'm sure this one is getting lengthy at this point. All right, so how about x times the square root of 2x minus 1 dx. All right, so again, I see a radical with stuff underneath it. So I'm thinking that that stuff is probably my u, right? But then if that's the case, then du is only 2 dx, all right? Well, I can compensate for the 2. I have the dx, but I also have extra, okay? So what do you do if you have extra? You come over to your u equation, okay? And you solve for x in this case because x is your extra. So let's see, I'm going to add 1 first, and then I'm going to divide by 2. Okay, which is the same thing as 1/2 times u plus 1. All right, keep that in mind. All right, so then I'm going to come back over here, and I still have a 1/2 in front. My extra is 1/2 times u plus 1. And then the square root is still there, and what's underneath it is u. So this becomes u to the 1/2, and all of this is du. Okay, so what can I do? Well, I can factor this 1/2 out to the front. That makes it 1/4. And then I can actually multiply these by distributing the u to the 1/2. Remember, that means I'm going to add a power. I'm going to add powers. And then it's more like a polynomial where I can apply some power rules. Keep the 1/4 out front, we'll distribute it later. All right, so add a power, divide by the new power. Add a power, divide by the new power. We put plus c out completely because even if I did distribute the 1/4 onto it, it would still be a constant. All right, and then to finish, I'm going to distribute the 1/4 and do a little bit of simplifying. And I'm going to plug the u back in. 6. All right. And then I've got one more like that for us. All righty. So I actually have two things raised to a power, but technically a binomial is more complicated. So that should be the first thought for your u, x cubed plus 3. All right, well, du then would be 3x squared dx. Okay, well, I've got the dx. I can compensate for the 3. But I have x to the 5th, not x squared. Well, x to the 5th can be split up into x squared times x cubed. Okay, so that's okay. I actually do have 3x squared dx now. But I have extra. I have an x cubed that is extra. Okay, but when I look at my u equation, it has an x cubed in it. So if I solve for x cubed, I might be able, or I should be able to replace it. All right, so let's come back over here and put it all together. What do we have? We've got the 1/3 in front. We've got u to the 1/4, right? X to the 3rd becomes u minus 3, and x squared times dx times 3 is my du. And then I can distribute and that makes it a lot easier to integrate. Okay, so the 1/3 is going to stay in front. Let's see, add a power, multiply by the reciprocal. Let's see, add a power. So when I do 3 times the reciprocal, I get 12/5. And then my plus c. And when I put it all back together and simplify, I'm going to distribute my 1/3 and I'm going to plug my u back in. Let's see, and when I distribute the 1/3 here, I get to reduce a little bit. Plug u back in and add c. All right, so once, but you've got to practice. You've definitely got to practice, but once you get the hang of it, it will get easier. The more you practice, the easier it'll get. All right, and so that's where I am going to stop with this particular set of notes. And the next video that I'm going to make is going to be on u substitution with definite integration.